students, welcome back to the next module of the chapter oscillation. Students, in the last module we have seen a very important concept of phase of SHM. We understood that phase is a physical quantity which describes the magnitude of displacement and the direction of displacement at any instant. Magnitude and direction is combinedly called as state of oscillation. Hence, phase is also a physical quantity which describes the state of oscillation of a particle at any instant. In this module, we'll understand phase more through some more examples. So let's consider one of the examples when the phase is pi by 6 radian or 30 degrees. So let's start. We know that equation of displacement is x is equal to a sin omega t plus alpha. Now for this numerical we have taken the phase as 30 degrees, that is omega t plus alpha is 30. Therefore x now becomes a sin 30 degrees. From trigonometry we know sin 30 is half, therefore x becomes, yes, a into half, that is a by 2. So we got an information that when the phase of the particle is 30 degrees, the displacement is a by 2. Let's understand the same through the phasor diagram. As we already know, we'll measure angles from OD in anti-clockwise direction. So our first case, the phase is 30 degree. So we drop a perpendicular particle M, which is at the foot of the perpendicular, and it's from mean position we get the value of x. So x is equal to a by 2. So when the phase is 30 degrees, we got the value as x is equal to a by 2 from the equation as well as from the phasor diagram. Now students, what about the direction? So for direction, let us recollect our table. Now students, in this case, if you have a look, the phase is 30 degrees. So where is 30 degrees? That is our first case. Yes. So whenever the phase is 30 degree, what is the direction of motion? So we can clearly see whenever the phase is 30 degree, the direction of motion is towards the positive extreme. So we can see in the phasor diagram now, the displacement is a by 2 and the direction of motion is towards positive extreme. So let's conclude. So can I say phase is equal to 30 degrees signifies that the particle is at x is equal to a by 2 and the direction of motion is towards positive extreme. Students, let's take one more example. Phase is equal to say 5 pi by 6 radian or 150 degrees. So let's put it in the equation of motion first. So in this case, we know the phase is 150. 150 students can be written as 90 plus 60. We know from trigonometry sin 90 plus theta is cos theta, and hence I can write this as a cos 60. Cos 60 is half, and therefore students, x once again becomes a by 2. So from phasor diagram, how will you go for it? Yes, we can clearly see this is our phase 150 degrees. We drop a perpendicular particle M and here is our displacement. Now the interesting part, where is the direction of motion? Students, recollect at phase is equal to 30 degrees also the displacement was a by 2, and right now in this case also the displacement is a by 2. But where is the direction of motion? So let's get back to our table. Students, 150 degrees lies, where is it? Yes, we can see in our table, it is our second case. Between pi by 2 and pi is 150. And where is the direction of motion, students? Yes, we can see clearly. Now the direction of motion is towards mean position. So let's summarize this case. So can I say 150 phase signifies that the particle is at x is equal to a by 2 and it is moving towards mean position. So clearly 30 degrees as well as 150, the position was a by 2, but the direction of motions are different. Let's understand through one more example. This time the phase is say 7 pi by 6 radian, that is 210 degrees. Again, if I put it in equation of motion, I get it this way. 210 can be written as 180 plus 30. From trigonometry we know sin 180 plus theta is, yes, minus sin theta, and therefore x becomes minus of a sin 30. Sin 30 is half, and hence x is equal to minus a by 2. Minus a by 2 implies that the particle is at towards left of the mean position. Yes, let's go back to the phasor diagram. We can clearly see now the phase is 210. Let's drop a perpendicular and the displacement is minus a by 2. Now where is the direction of motion? So we can clearly see this time the direction of motion. Yes, our angle lies between pi and 3 pi by 2, and the direction is, yes, it is towards the negative extreme. So I can conclude that whenever the phase, in this case, when the phase is 210 degrees, the particle is at minus a by 2 and it is moving towards the left extreme. So that's all in this module, students. See you in the next module.